is called the substitution rule. So give you a little background on what's going on here. This rule is going to increase by a whole generation worth the functions that we can now find antiderivatives. You might think we can find a lot, which we can, but wouldn't you like to double that number or even quadruple that number, do even more and more difficult things and still be able to find our antiderivative? And the substitution rule is basically one of the major rules for doing that. Of all the rules that you'll learn in this class, next to probably the power rule, I would put this one down as the most useful. So it's a pretty important technique to get good at, because you're going to use it a lot. And diverging as I do, I was teaching my Calc 4 today, and one of the questions came up and we needed to integrate something, and boom, it was a substitution rule technique. So you gotta, be aware that this fella is important. So we need to be good at it. Secondly, in Calc 1, we got rules like the product rule, the quotient rule, a little bit less so the chain rule, but weren't the kind of formulas where you plug things in. It was f dash g plus f g dash, that kind of thing. It was kind of a formula, and you plug the bits in and you got the answer. The substitution rule is not really like that. The substitution rule is more like a process, and it is less precise. It's not like this guy is f, this guy is g, this guy's derivative goes here, this other guy's derivative goes there. It's nothing like that. It's much more a process. So let me show you a very simple application of the substitution rule. Imagine I wanted to integrate that function, right? Find its antiderivative. If you use the techniques that you know right now, isn't the only way you could do that is by foiling that out, right? Multiplying it all out. Couple of days from now, wouldn't you have a polynomial that would fill that entire piece of paper? And then wouldn't you just use the power rule on each of the terms? And by that time, you would be so fed up, you wouldn't want to ever do another one of them in your life again. So it's not a very efficient way to do that puzzle. But this kind of question is almost like designed for what's called the substitution rule. The name substitution gives us a little bit of a clue. Because step one is we change this question from an integral that uses x to a different integral that uses another variable called u, and we're going to use substitution to do that. And the variable u, in this case, is going to be x plus 10. Now, it's not a coincidence. It's not random. The reason I'm going to call this u plus 10 is, won't this be u to the power of 10? U to the power of 100. Would you agree? If u is x plus 10 to 100, won't this become u to 100 if I make u x plus 10? Seems reasonable. Now, what I can't do is just call that du, but I can find out what du is equal to, and this is part of step one. You differentiate u with respect to x, and you get 1. Okay. Now, you might have wondered why this notation even gets used, because mathematically we don't like writing lots of stuff, right? We prefer to call it f dash x, which it is, but this is the reason. It's not really a fraction, but they are similar in a lot of respects. The du and the dx are like separate things. They're called differentials. And can you imagine a little, I call it a crossover. Can you imagine that this would be the same as that? Now, what does that tell me? Oh, it tells me that this guy can be du. Don't always assume that that's going to be, because the next question, that's not going to be a straight match. Now, what is that guy? Well, isn't that guy a good old-fashioned simple power rule? Right? U to the 100 du is a simple power rule. You add 1 to the power, and you divide by the new power. And then you add your little c. So step 1 is to do this. Step 2 is to get to here. One more step. Return the u. The antiderivative of this is that. Now, if I cut out all the talking, I could have done that in about a minute. Can you imagine how long it would have taken if we had to do it as a FOIL out and so on? That was probably the simplest one I could think of. So let me up the ante and do a 3x plus 1 to the power of 11, because I want to. Okay. What do you think the u sub should be in this question?
That's 3x plus 1.
Agreed. And now I'm going to do differentiate u with respect to x, and you'll get 3. And I'll do the crossover, and you get 3 dx. And then you isolate the dx, because what you're trying to do here in this bubble of work is you're trying to find out how you can replace dx with something, right? So I'm going to replace this guy with u to the 11, and I'm going to replace the dx was 1/3 du. And I'm just going to write this a little bit nicer. So this integral, using the substitution rule, has now been converted into this one. Only now I can use the power rule. Add 1 to the power, divide by the new power. And then to finish, oh, by the way, that's step 3 here. Convert back to the x's. Wow. That's kind of cool, isn't it? Show you another one. Let's do the integral of 2x, the square root of x squared plus 1 dx. Okay. I need a u sub. And the u sub I'm going to choose here is whatever is inside the square root. So it's x squared plus 1. And when I differentiate this with respect to x, you get 2x. And when I do that crossover thing, du ends up being that guy. And then if I divide both sides by 2x, we isolate the dx. And then do my substitution. I'll just leave that as 2x for the time being. The square root of that gets the square root of u, and the dx gets me 1 over 2x du. These cancel out. So the substitution rule has taken this quite awkward, ugly integral and has now converted it into this. If you do the substitution rule correctly, these guys here should be much easier to do. They should be just usual power rules and so forth. Right, any questions so far? Because this is quite unusual, right? This is a one-off thing. I don't think you've seen anything quite like this before. Are you happy about how I chose x squared plus 1? Are you okay then with differentiating, doing the little crossover thing, and finally isolating the dx? And once that's done, leave the 2x alone for a minute, make that the square root of u, replace the dx by this thing, look at some cancelling, and you got that. What do you think I'm going to do next? I want to integrate that, right? I want to find its antiderivative. What am I going to do next?
Put the x squared plus 1 back in?
Not yet.
Okay.
That'll happen. But I want to integrate that, right? I still haven't integrated. I've only changed it into an easier integral. I haven't actually done the integral part yet. So don't you have to turn them into half power so you can use the power rule? Add 1 to the power, divide by the new power. And then we'll do what you were asking. Well, maybe not yet. Make it look pretty. And then do what you wanted. Replace the u with that. Have you noticed in those 3 examples that I'm not using any formula? Isn't it really just a process? Okay. What I'm going to do now for the next, 10 minutes or so, is I'm going to show you a whole load of integrals. And the only thing we're going to look at is what the u sub would be. We aren't going to do any more than just that. Okay, here's a pretty varied bunch. Each one of these needs to be done by the substitution rule. The first thing that you need to get correct is that you need to do, or you need to choose the correct u sub. And because there are so many different kinds, you have to be able to look at a function and understand who the u sub is going to be. So here's a set of rules that I'm just basically telling you. If you ever have an integral with an ugly thing in the brackets to the power of 10, then the u sub is whatever is in the brackets, typically. If ever you get an integral and there's a square root of something, the u sub is typically the thing inside the square root. If ever you get a u sub and there's an e to the power of something or a 4 to the power of something, right? Something like that going on, the something will be your u sub. If ever you have a trig, a sine of an ugly thing, a cosine, a tangent, a secant squared of something. Now, the reason I'm saying something is it's okay for that to be sine x. That wouldn't be a u sub, right? But if it's a sine x cubed plus 4x or something, then it's a u sub. That's okay. If it's an e to x, that's not the u sub. But if it's an e to the sine x, e to the x cubed plus x, right, e to the something, then it's a u sub. And when you have a fraction, the u sub is the bottom, the denominator. So if you look at all of these and they all look quite different, isn't there different ways of deciding who the u sub is? Great. Now, what the rule I've just given you is good for about 9 out of 10 questions. So if you stick to those rules, 9 out of 10 questions, you will pick the right u sub and you'll probably get the, not probably, you'll get the right answer at the end. There's always going to be exceptions to every single one of these rules. But I'm not going to talk about the exceptions right now. We can do that tomorrow. We're going to just focus on the ones where the u sub that you think you should be using is the one that you do use. So I'm going to try and give you another bunch, but I'll let you look at them and you can tell me who you think the u sub should be. Okay, there's a fair old mixture. Let me see if I can cover the ones that I don't want to look at out the way. Now, I need a u sub. Who shall I pick?
Four x to the fourth power plus 2.
Using the rule, if you've got an ugly bracket to the power of 3, the thing inside the ugly bracket is your u sub. Who's the u sub?
X squared plus 1.
Using the rule, if it's e to the ugly guy is your u sub. Correct. Who's the u sub?
Cosine x plus 1.
Correct. Ugly guy inside square root is your u sub, right? 9 times out of 10, this is going to work. So that's good, right? We'll talk tomorrow about the exceptions, right? The weird ones where you have to change the rule a little bit. That one's a bit sneaky because there's two rules. Isn't it an ugly guy inside the square root, which is x squared plus 1? And isn't it a fraction, so it should be the guy in the bottom? Now, you can't have two u subs, only one u sub works. Which one of those two do you think is the u sub in this question? X squared plus 1 or the square root of x squared plus 1? Which rule do you think wins?
X squared plus 1.
Correct. Any idea why you picked that, or did it just seem the right choice?
Because generally when we turn a square root into a u, we don't take the square root with it. That's what I've seen.
Good. On the other hand, isn't this one pretty obvious who the u sub is? And what would the u sub be in this case?
Denominator.
Right, just the same guy, right? X squared plus 1. What about the last one?
Sine x.
Agreed. Using the rule, e to the ugly guy. So that was just a little, sorry. Yeah.
So for the number 3 one, cosine x plus 1 is your u sub.
Correct.
But you're keeping you're keeping the square root of, right? You're just putting your u inside there.
Yes.
And then
Tell you what, let's do that one. Show you the whole process. So suppose you were going to find this guy, and you were saying your u sub is cosine x plus 1. I typically do my u subs as a little line at the side. That's kind of how I write it down. Okay, so if you differentiate with respect to x, won't this turn into a negative sine x? Remember, differentiation of a cosine is a negative sign. If you do the crossover, you basically just, well, I don't know, isn't it a bit like picking the dx and sticking it there? Right. Now you always, and I suggest this, you always isolate the dx. So in this case, not a lot of room here. Negative 1 over sine x du. You know, if you divide both sides, you get this. Now let's see what happens. If you don't know what to do with something, just write it down. So I'm just writing sine x down right now. Now this comes to, I think, what you were talking about, you, Evan. Wouldn't this just be the square root of u? So the square root's still there, but it goes there, right? And what about the dx? Well, the dx looks like that. Now, if you have done a good u sub, you will find out that these guys disappear, and the only thing that should be left should have u's in it. If you ever do a u sub and you go through this process and there's like a x cubed left over or a sine x left over, or something with an x left over, it either means that you've messed up somewhere here or you've chosen a wrong u sub typically. Right? So if you had two choices and you picked the wrong one, you'd probably find out pretty quickly when you came to do the substitution part, which is what's happening here. Now this one's almost identical to the one I did at the start of today, because don't you have to turn square roots into half powers? Now I can integrate. Add 1 to the power, divide by the new power, and then style point it. And lastly, replace the u with the cos x plus 1 cubed. And that's the answer to the integral of that. Did that help answer what your question was going to be, Evan? Or did you already figure it out?
I'm going to research more of this after class, I think.
Okay. So let's see if we can think. When you're looking at these questions, do you feel comfortable about who the u sub's going to be? You feel that you know most of the time who to pick as the u sub? Would that be fair? Right. So it's what happens next is takes a little bit more thought, right? Okay. Let's choose somebody. Well, I've got a whole bunch over here. Who do you want me to pick? Already done that one. Which one do you want to do next?
Last
Jessica?
one.
Last one. So we have a cosine x with an e to the sine x, right? It's e to the power of sine x. That's a pretty weird looking function, isn't it? I guess if you put that into the calculator, some really weird thing might happen. Now the u sub is sine x, right? E ugly guy's the u sub. You differentiate with respect to x. Well, differentiate sine, you get cosine. You do what I call the crossover, which is basically you cross the dx over to the other side. And lastly, you isolate the dx. In this case, divide both sides by cosine of x, and you got that. So all the pieces are in place. We just need to figure out where they go. I'm going to go integral. I'm going to write down the cosine x. Instead of e to the sine x, it's now e to the u. Instead of dx, it's now 1 over cosine x du. Just as I was hoping, these things cancel out, and we are now just left with that integral. But I know how to do that. E to the u plus c. And then to finish, return the u and replace it with sine x.
I have a question.
Yes.
I know this problem kind of looks convenient in a sense where we know that the derivatives kind of all work out in this way, but what if the cosine x times e to the power of u, what if that cosine was something else? Would this just not work at that point?
Correct. The substitution method is not infallible. It can't be used in many situations. Right? There are lots of combinations out there, and the u sub, right, the substitution method works for some. It works for this one, but it doesn't work for all of them, right? And that is okay. We have other techniques for the other ones. Since you're in a section where all the questions are use the substitution rule, then you don't need to worry about all the integrals in the world that don't work with the substitution rule, because you're never going to see those guys, right? So I don't know if that makes you feel better or not, but you're quite right. The substitution rule doesn't say, oh, well, once you learn this rule, you don't need to learn any other rules, right? You don't need to learn, for instance, there's going to be another rule later called integration by parts. And there's other techniques called trig substitution, and there's another one in there that my mind has forgotten about it. X subs, yeah. So we have lots of other techniques for other situations. But right now we're only going to deal with integrals where the substitution technique works, right? So we know it's going to work because they pick the questions that it works with, right? Does that help?
Yeah, thank you.
Okay, so kill that one off. Who do you want next?
Let's do number 4 just in case.
This horrible one?
Yeah.
Good choice. So let me remind you of the first question. What is the u sub here?
X squared plus 1.
Only x squared plus 1. Which is ugly guy inside square root. Now, if you differentiate this guy, you get 2x. Right? Differentiate this with respect to x. Do the crossover. And then isolate the dx. If you choose the right u sub, won't this process here be pretty standard? You do the same thing every time, right? Differentiate with x, do the crossover, isolate the dx. Then you go over here and you say, okay, I don't know what to do with that 2x. If you don't know what to do with it, just write it down. Can I do something with the square root of x squared plus 1 in terms of u? Yep. Since x squared plus 1 is u, this becomes a square root of u. Can I do something with the dx? Yes, that's what this is about. And really maybe more nice than you were perhaps expecting. Don't these guys cancel out with these guys? And what we're now left with was basically this fella. So if you do a substitution question correctly, the ugly one that we don't really know what the answer is will turn into a new integral where we should be able to get the answer to it. Now, it doesn't mean that we're finished. Very often you have to do things to get that integral, but it should be situations that you're comfortable with. Won't I have to turn this into a fractional power of u so I can integrate it? And so what power of u is 1 over the square root of u? And be careful.
-1/2.
Correct. So add 1 to the power and divide by the new power. Convert back, right, style points, and then convert back into that guy. Now, if you wanted to prove that this technique works, you're just going to have to trust me on this one. But do you know, if you differentiate this, you will eventually get can you trust me that it does work, right? You can always take your answer and differentiate it and it will return you back to the original. I think substitution, because it is such a different way of doing things, is what I found is that the first 2 or 3 examples look kind of haphazard and, you know, I can't quite see where he's going each time. But by the time the third one turns up, it tends to get a little bit more of a flow, right? I need a u sub. I do this stuff. I turn all the x's into u's. I should have a nice integral. Find the answer to that integral, and then turn everybody back into x's. That's kind of the flow. So this is me picking a question now from the homework. This is basically like question 1. Okay, let's see, we got the flow here. Who's the u sub?
X cubed plus 9.
I'm hoping here that the vast majority of you now kind of know who the u sub is in this question, right? They kind of know where to look. Isn't it the ugly guy inside the square root rule? Now you differentiate this with respect to x, right? 3x squared plus nothing. You do the crossover. And then divide both sides by 3x squared. And that's what I call isolating the dx when you do that. Now you go over here. Will I write down x squared, or will I write down something with u's in it? What will I do about the x squared right now?
Just write it down.
Yeah. And won't the square root of this become the square root of u? And doesn't the dx always gets replaced by whatever this is? Now, if we've done this correctly, shouldn't anything that's got an x in it disappear? You're okay to have numbers left over, but not x's. So I'm going to say that that x squared cancels out that x squared. And that leaves me with 1/3 the square root of u du. Square root of u seems to be a popular question right now. Are we good so far? Okay, where do I go next?
Now we integrate.
And how am I going to write the square root of u so I can integrate?
1/3 u to the 1/2.
Agreed. And now I'll do the power rule, which is add 1 to the power. divide by 2/3 is the same. It's divide by 3/2 is the same as multiplying by 2/3. So that's where that weird 2/9 came from. Do a style point thing. Now, what I mean by that is, isn't the rule make it look like the original? Don't leave it as 3/2. Call that the cube root, the square root of u cubed. And we're almost done. What's the last step in this process?
Substitute it back in.
Doesn't it have a reasonably nice flow to it, doesn't it? Okay. This one is like question 2.
I'm sorry, can you just show me just the very end of that one? I was kind of working along. I forgot to look at the answer. Okay, that's what I got. Thank you.
Okay, I need a use up. There are not a lot of choices here. Hopefully the obvious is the one you're picking.
4 minus 5x.
That is using the rule, if you've got a fraction, the bottom guy is very often the use up. Now in this case, the derivative ends up being -5. And the crossover ends up being that. And when you divide both sides by -5, you get that. So once you do a U sub, you go through bump, bump, bump every time, right? Same thing, same process at least. Now you go over here. Well, this doesn't actually require too much. Isn't this 1 over that guy? So it's 1 over u. The dx gets replaced by a -1/5 du. And I'm going to call this -1/5 1 over u du. In my brain, that just helps. Okay, let's integrate -1/5 1 over u. Well, forget about the -1/5. Integrate 1 over u then. That's easier.
Natural log of u.
So isn't -1/5 of it just -1/5, the natural log of u? Plus c. All right, that's the integration done. Aren't we pretty much almost finished now? Just one more line and call it good. And the one more line is convert back to x's. Substitute back. Can you hear my dog barking in the background? That's Maggie. Celeste, if you've got some time, what is it? Come here. Come on. Come here. I'm not going to hit you. Come on. Come here. This time, yeah. My wife went, I said, I'm not going to hit you. My wife went and said, yeah, this time. Oh, okay, my wife's going to take care of that. Yeah. Okay, so, oh God, I'm so easily distracted. I think I finished this question, didn't I? Are we good with this one? We can move on?
Yes, we finished this one.
Okay. She sounds like a seal, doesn't she? Sounds like I've got a seal in the house. Okay. I tell you what I'll do for the last few minutes. Will you all say hi right now in case I forget to do that at the end? And we are going to have a look at what some of these homework questions look like. Okay. I think I switched over. Are you looking at question 7 right now? Okay, suppose you're, oh, darn it, the answers are there. That's annoying for me. I've got to remember. Go away. The answers are just, aye. Sorry about that. Are you going to wait a second? I got weird day today. Nothing comes out the way you want it to. Almost back in. I think my WebAssign timed out, and that's why I couldn't get what I was looking for. Okay, I got a view. Sure, I can use it. Last few seconds, come on. There we go. Okay, I'll just make it a little bit bigger. Boom, boom. Okay, question 7 is not really a good question because don't they tell you the U sub? So that's nice when they do it. So anybody recognize who the U sub should be in question 8?
1 plus cosine of t.
Correct. What would the U sub be in question 9? And you might have to think about that one.
Seven minus e to the u.
Agreed. Are you all agreeing with that? That's actually the one that would work. Okay, you might come across something like 10 that is scare the EBGBs out of you, but actually the U sub is easy. Who is the U sub in question 10?
Four ax plus bx to the fourth.
And we'll probably do that one tomorrow, but trust me, that's a U sub. Isn't it inside the square root? That's pretty much it. So won't the next one be 33 plus e to the x? Oh, this one's a sneaky one. What would the U sub be in question 12?
Cosine of 28t.
Yeah. Sometimes you have to trust the math and say, oh, I don't like the looks of that one, but trust it. Eventually that one works. Eventually. That one is decidedly simple and therefore very easy to not know what to do. What is the U sub in 13?
Pi t over 2.
Yeah. What about in 15?
Negative x to the 26th.
Yep. What about 16?
X minus 2.
We are getting quicker, aren't we? The best way to do these kinds of questions is to practice them till you're bored stupid with them. Because if you see enough situations, it just becomes second nature. You look at it and you say, yep, U sub is x minus 2. Who's the U sub in 17?
E to the z plus 40z.
Well, e to the z plus 40z, but I'll let that one slide. Oh, God, they told you that one, told you that one, told you that one. What about question 22?
4 minus x squared.
What about 23?
9 minus x.
9 minus 2x, yeah. What about 23?
You're showing 26 and 27.
Oh, sorry. I don't know where the 3 came from. 26. What's 26?
The denominator.
Yeah. Well, that's a nice way of saying it. What about 27?
4x plus 5.
28?
X squared plus 29.
29 is 1 plus 7x. The ones that I'm skipping by are because those are special cases. Whoa, cool. Look at 31. Who's the use of?
Sine of 4x.
Oh, well done. Yes, sine of 4x. How about 1 plus 4x squared for this one? Actually, 1 plus 4x would do better. You haven't seen anything quite like 33, although you should be able to tell who the u sub is, even if you've never seen it.
It's a squared minus x to the 9th.
Right. Now, if you can look at a question, as we've just scanned through virtually most of the homework questions, you should be getting up to speed and feeling more and more comfortable about who the u sub should be, right? And that is for the 9 out of 10 cases. Tomorrow we'll confuse you by showing you exceptions to the rule, but they're rare, right? They're not the thing you should see too often. Now, if you can do the u sub right, shouldn't you be able to do all that du by dx of, and then substitution? If you do everything right, won't you have a nice integral with nothing but u's in it? And that nice integral with nothing but u's in it should be reasonably easy to do. And so you get the answer in terms of u. And then you finish off by turning all the u's back into x's. And that's the flow for every u sub substitution question that you're ever going to see. And we have reached the end here, so I'll hang about for a few minutes because some of you may have some other questions, homework questions or whatever. Otherwise, I'll see you tomorrow. And we learned some cool stuff today.
All right.
Thank you.
All right. And Evan's back to being the scary guy.
It's time to do some hacking.
Time to do some hacking. Okay.
Thank you.
You're welcome. Bye-bye, guys.
I said a quick homework question if you had some time.
I have time. What you got?
Awesome. So on question 4 on the WebAssign, let's see, it was 5.4.
Right.
They were
Question.
asking for like a specific integer on the WebAssign, and it kept telling like, or a fraction. But the way they were asking for it was really weird. It like wouldn't let me like put in a fraction.
Let me see. What 5.4 question number
4.
4. Right. So
Mhm.
you hold on a second. I'm going to go in and get that specific question.
Yeah, no worries.
5.4. So that's an indefinite integral. Gotcha.
Yeah, it was the
Right.
velocity and acceleration one.
Okay. Do a view on that. And jump to 4. Right. I won't quite get the same numbers, but I will get the same looking question as you. So you tell me if this looks kind of like the same version of your. Okay. Are you looking at the acceleration question?
Yeah, now I am.
Right. Okay. So I probably have to shrink it a little bit to catch the, yeah.
Oh, it
So-
happens to be the same numbers. It's fine.
Oh, well, that happens. When they're in, yeah, it's sheer good luck. And
Right.
those red numbers get randomly generated. So your question's not the same as George's, you know, just
Right.
whatever. So did you get t squared plus 2t plus c? And that became t squared plus 2t take away 15. Did you get that?
Let me unmute. That was my velocity one.
Yeah. So did you get t squared plus 2t take away 15?
Yes.
Right. Now, I'm going to show you the gist of what the problem is. And the question could have been much more specific, and they weren't. So I blame the question, not you, because there's no indication that this is what they wanted. But can you remember, you remind me if I write this down wrong, but I believe that was your guy, right?
Yeah, that was.
Right. Now, if you plug that guy into the calculator, actually, maybe that'd be a good idea. If you go y equals, oh, okay, clear these guys out. And that's going to get me what? X squared plus 2x subtract 15. Right. And I'm only interested in what, from 0 to 5 in this story?
Yeah, that's what it was looking
So
at.
I'm going to go 0 to 5. Now, I know mine says x's, but can you pretend to say t's? It's not a biggie. Right. Now, I'm going to do zoom to fit and show you what the problem is. This is what the guy looks like. Now, if they had asked for a word called displacement, if they'd used that word, you would have done the integral from 0 to 5 of t squared plus 2t take away 15 dt, and you would have got the right answer. But it didn't. It said distance travelled, which means that you need to find out where that guy is. And I believe he's at 3. And you're going to find this area, and you're going to find this area, but you're going to do them separately from 0 to 3 of the thing, and then you're going to do from 3 to 5 of the thing. And that's what I mean by the thing. But won't this come up as a negative? But you make it positive. And that's how it works. So when they say distance, which they do, they want the area as a total positive number. And when they use the word displacement, then you can just do that. And so in physics, displacement and distance are not the same thing. Displacement means how far away from where I started am I now? Distance is how far did I walk to do all that? So could you imagine a journey where you left your house, went 5 miles north and 4 miles south? Your displacement would be 1 mile north, but your distance traveled would be 9 miles. So that's kind of what went wrong. Does that make sense?
It does. The way that they were asking for the answer was just so obscure. I think was also what I was getting really kind of
It's
messed
just,
up with.
yeah, it's not your fault. I think
Okay.
anybody looking at that, I actually didn't even notice that the first time I looked at it. The first time I looked at it, I thought, they just want me to do that, and that's fine.
Right.
Because on almost every other question, that's exactly what they wanted us to do, right?
Right.